predictions. How is the soil moisture? This is the anomaly in millimeters of water. So this is valid for May, the last week in May. So more or less we had a little bit of drought in the California, and well, a lot of rain in Texas, including the Labor Day precipitation, floodings, and other events. So this is what we have right now for the soil moisture, and we have none here, no information. So right now there are 4 basically models that are being used. One is the Mosaic, the other one is NOAA from NCAR, BIC from Washington University, and SAC that uses the National Weather Service. So basically you have to take into account not only the atmosphere but also vegetation and the soil. So what now is done through the NLDAS, which is the North American Land Data Assimilation, is that they're running the models. So they take the information that comes from the different stations, they put it into the global model, they couple it with the land surface model, they do the area analysis with the observations, they put some corrections, and they continue this iteration in order to produce the state of the soil moisture in North America. And the resolution in North America is 1/8 of a degree, which is about 12 kilometers. And globally is 1/4 of a degree resolution. So it's still coarse. So now what they do is do the ensemble with the different 4 models of the LSM, and they can do a 6 months seasonal forecast for soil moisture, right? So this is what it is expected on October this year. This is on May, starting computation in May. So we still see some drought in California, and this is what the models predict. The CFS version 2 predict for October of this year. I'm sorry. And if we see a soil moisture forecast for the months of June, July, August, September 2012, 2015. Well, this is the forecast, right? The resolution is not very good. And if we look at Northwest Mexico and South U.S., well, we would like to have more information besides that resolution. Also, we can see there some gray lines, gray spaces here, which means that the skills for the models are not very good, so there's no information. So that has to do obviously with the variety of landscape of Mexico, and we would like to have a little more better resolution for this. And this is doing the hindcast climatology from data from 1999 to 2010. Okay, so this is what we have right now. So we have a wish list. Yes?
Can you go back one step?
Yes?
If you were a betting man,
no, I'm not.
Would you put your money on this soil moisture forecast for Sonora?
Well,
how much would you put?
Well, all the money has gone to the elections and politics, and no money has been left for research. So I cannot put more. Okay. All right. So more realistic. So we have a wish list of what we want to have. So if we would like to study the dynamics of drought in Mexico, we need to build an historic moisture data, like 30 years of moisture, soil moisture, which we don't have. And after having that, we can include this soil moisture data into their models. And then, for example, I mentioned the NLDAS, for example, covers from 25 degrees north, so there's no validation of the NLDAS in Mexico. So we would like to have a Mexican NLDAS, right, in order to use the CFS version 2 and then downscale to higher resolutions. Also, we need to improve the skills for the regional models, because as we showed here, there's some gray areas we cannot predict with that models at that resolution. Okay, so this is where SMAP comes into place. So recently there was a new satellite launched, which is going to try to provide measures for land surface moisture and freeze-thaw state. In 2 or 3 days resolution, it will repeat the whole Earth planet in 8 days at 685 kilometers, and it has 1,000 kilometers SWAT. Okay. So, what are the science applications of this new satellite? Well, it will try to help us understand processes linking terrestrial water, energy, and carbon cycles. We would like to have more estimates or better estimates of global water and energy fluxes at the land surface. We like to quantify the net carbon flux at the northern hemispheres and enhance, obviously, the climate and weather forecasts skills. And also, this can be applied then to flood predictions, knowing the soil moisture content, and try to monitor drought. More than the monthly reports we get from the Servicio Meteorológico. This is more or less how the satellite is going to cover the whole planet, and gets a lower altitude at higher latitudes, right? So that's why they try to study how much, how rapidly the freeze gets thawed. Okay. Information is going to give us the soil moisture in the top 5 centimeters of the soil. It will measure the water content of vegetation as long as it's less than 5 kilograms per square meter. The radiometer has a 36 kilometer resolution. The radar has 9 kilometer resolution, and it will give you a product every 3 days. It will produce a lot of data we can try to analyze through the different data mining techniques. This is one picture from March, from the week of March 31 to April, of the temperature at Earth, land surface. This is what we're going to get. This is a 36 kilometer resolution from the radiometer data, and combining radiometer plus radar, we'll get a 9 kilometer resolution for, this is soil moisture content. This is the scale. So blue is more moisture. So this was May probably. See, this is how the satellite is swapping the surface. So this is how it's going to be downscale. This is from the week of May. So they're still on the what they call calibrating the data and validating the data. So right now, for example, they're calibrating data. This is a picture from Australia. So they have a schedule for liberating the data by November of this year, and validated measurements available next summer. And remember, it's going to be a 3-year mission, or 36 months. So, for example, this is a picture of, they have a soil observation network in Texas. They measure soil moisture in the top 20 inches. So they're going to compare it to the data coming from SMAP. So what we see here is an opportunity to calibrate and validate regional weather and climate models for improved higher resolution. Remember, we will have 9-kilometer resolution, and that will help us to improve the forecast for the North American monsoon region. And also, I don't know if somebody is validating or is going to be validating the SMAP data in Mexico. Remember that everything has to do with the land cover, how is it registered, and how is taken into account by the different land surface models. So that's something that we need to do. So in this slide, I know I'm between this talk and your lunch, so I'll be synthesizing here. So what we want to do in the near future, well, just invitation of collaboration between our different institutions in order to develop the diurnal, atmospheric, and land data fluxes from the different sites we're taking measurements and trying to feed them into Surfex. To improve the land surface model over Mexico in this region, as Enrique mentioned in the last talk. We would like to construct land data analysis, fluxes, and land state with that network, and also do a WRF assimilation of soil moisture, taking into account maybe just a regular WRF or WRF plus hydro, and try to develop some strategies to understand the dynamics of drought in Mexico. So that's what we are aiming for, and the invitation is open. So that will be my talk, and if you have any questions. Enrique.
To my knowledge, there isn't any SMAP validation in Mexico. They're treating the work that's going to be done in Walnut Gulch as representative of the whole monsoon region.
Mm-hmm.
And we know that Walnut Gulch is a shrubland with low biomass.
Okay.
So it's not very representative of our deciduous areas.
Well, we would start getting that data at the end of the year, so we can try to validate or at least have some points of some reference points. Yes. See?
Carlos, I think you mentioned this in terms of the kind of problems as well of SMAP. One of them is precisely vegetation.
Mm-hmm.
There is a threshold where the system does not work anymore. There is another caveat as well in terms of but we can go through that. It's not that diminishing this part.
Mm-hmm.
The other part is that it provides just the top layer.
Okay.
So it doesn't reach the root zone.
No.
And that's another component. So my question goes in that end. Have you thought about how you will handle this part?
Well, I know there's a lot of parametrations along the way. The resolutions of the land surface models used in the models are very high. I mean, not very high, but we could work in having some points of reference in order to improve the models where we have data. Right now, we have zero soil moisture data, and well, all the models are working just with precipitation.
Right. Well, that's another comment there. We had a conversation probably a month ago with the LS people, because there is an update of one of the data sets, 116-degree resolution from southern Canada to southern Mexico, and they are interested in getting that series of updates. So it is likely that now LDAS might jump into a high resolution and covering that whole domain.
Yeah, but that's where, well, LDAS stops here. So and actually that cuts off in this region.
That's what I mentioned. The conversation is to extend it to the southern part of Mexico. One of the let's say the problems we have is getting the data. And then Agustin Robles and Ben Levne, myself and other people are working to that in to see if we can go through. But that's just to
Okay.
comment on that.
Yes. Well, our approach is Mexico policy on having different observational sites goes with current politics. So every time you get 5,000 new sites, and they run for 2 years, and then there's no money for updating them or calibrating them. So the data comes into bursts, and well, if you're doing climatology, you cannot work with that. So our hope is trying to construct it using models coming from the large scale into downscale. And that's what we have, and then we can try to marry those information with lower scale or local scale models.
If I can interject.
Yes, you may.
I'm not too sure if Juan Carlos is here from the National Weather Service. Is he here now? No. Well, maybe I can say anything now. Everything, rather. Well, 2 years ago I talked to Juan Manuel Caballero, well-known guy to us, and he said he would set up 100 stations with soil moisture sensors for just the first 10 centimeters deep. And so far we haven't heard anything about it. I mean, it's just maybe a couple of stations that actually have measurements in the northern part of Mexico, and nobody is analyzing those. They don't even know what soil textures or land use, land cover information there is around it. So I think we are willing to do all these things, but we don't really have like a good strategy, and obviously we cannot really rely on the weather service. We have to pull up all our resources as universities here and abroad just to have something going on, a minimal network that could actually work. So that's just my...
There's a soil moisture network that runs on the U.S. side and includes one station in Rayon, the Cosmos network. It runs with, well, the theory is that all the cosmic rays come into the land surface, and then they liberate neutrons from the atomic interactions, and these systems just count the number of neutrons. So they try to compute more or less what is the total amount of soil moisture in that region. We only have one station in Mexico. We can extend that as long as we can get any funds.
Let me comment on that. The analogy is a Cosmos station, in my mind, for hydrology is what GPS is for atmospheric science. It's a very usable installation. It's a larger footprint. There's a global network now of people who are installing Cosmos stations. If I were to invest in a nationwide, Mexico nationwide observing system for soil moisture, I would put 100 Cosmos stations. And then we get somewhere with validating SMAP and getting better models, etc.
It's like $20,000, right?
Yeah.
It's not that big, an investment compared to a radar, for instance.
Maybe we reach.
Let's ask him. Yeah, we have to.
Again.
Again?
And again.
Yeah. Enrique.
Just a final comment on that. We have some good experience in installing the Cosmos. One site is in Sonora. There are a site in Arizona and New Mexico that we also manage. The calibration of the sensor is not that difficult. You know, it's one of these things that it's plug and play in a sense. Once you set it up, it doesn't give you much problems. It's not
Uploads.
like an ecovariance tower that's maintenance intensive. It's more like a GPS sensor that's less maintenance intensive.
It has the satellite transmitter, so the data is in real time.
Yeah. Okay. Well, thank you.
Okay.
Carlos.
Okay.